Hello, welcome back to Machine Learning AI. In this video, we are going to discuss a clustering technique in machine learning. We first see what's clustering and then we implement using Python from scratch. I'll demonstrate how you can create data and then cluster it and visualize it with some visualization libraries in Python. Let's begin. So, we'll try to answer a few questions in this tutorial. One, what is clustering and where it is useful, and the types of clustering algorithms, and we specifically use k-means algorithm and implement it from scratch. Let's see what clustering is. Clustering is a process of identifying natural groups in the data. So when we do cluster is when we do not have specific labels associated with the data points, which we call as unsupervised learning in machine learning terminology. If you see this image, you are given some data set without any labels, as these are colored though initially you don't have any labels. The clustering algorithm will help you to identify the groups, naturally happening groups in the whole data set, and when it is useful, it is very useful in detecting patterns when you don't know what you are looking for. For example, you have a lot of data collected in your retail store and you want to identify your customer shopping patterns. Based on that, you may increase few products and gain good ROI, returns on investments. And you can group emails like as you see in Gmail, there are multiple segmentations like social, private, and other options as well, right? And also for image segmentation. And coming to the clustering algorithm types, on the top there are two types: partition based, hierarchical based. In partition we see k-means, mixture of Gaussians, spectral clustering. In hierarchical we see bottom up and top down. K-means implementation from scratch, pseudocode will looks like this. So you have to choose how many clusters you want, which is k. Here in this example for visualization is I choose k to be 2. Then once you decide that variable and you have all the data set to cluster, and what you need to do is you need to find distance from each data point to each centroid that you have initialized. Then assign to group 1 if distance of the points from the centroid 1 are less than centroid 2, otherwise assign to group 2, simple grouping. And once you have these groups, and compute mean for each of the group and update centroids. Repeat until there is no change in the centroids. That's it. That's very simple, straightforward algorithm. And let's see how we can implement from scratch. So let's import all the required packages. Let's use NumPy and Matplotlib and Cbon, and we use scikit-learn datasets for creating datasets using make blobs. A broad few helper functions to make things easier. One is to plot k-means. It takes data and centroids and plots them, all the data and centroids on 2D plot. And find distance will take data and centroids and compute L2 norm, Euclidean distance, whatever you call. So as distance 1 and distance 0 it returns, and using this distance we try to find the groups as I described above, group 1, group 2. How we update centroids is using this function. We take data and we take this S, which has grouping information, where S is equals 0, that means group 1, S is equals 1, then group 2, and using this information on the data set, compute new mean, which is gonna update the existing centroids, right? So let's move on, and I have defined some plotting settings here. Let's create some data set for clustering. Here we are using make blocks to create data set, creating 1000 samples with 2 features, which is 2 dimensions, and making sure we get 2 clusters. And I've also added some standard deviation so that data will be sparse on this 2D space. And just to make sure that of repeatability, if you try this example, I set it to random state 10 so that you can actually see this and repeatable example in your notebook as well. So we are using plot scatter to plot this data, and you can see this is our cluster. And on the numerical side, the data will look like this. So 2 dimension, 1 x1 and x2 you can call. And we also initialize centroids randomly, so these are the centroids. And now to plot data and centroids on 2D, so we use plot k-means, data and centroids will plot. So these are the initialized centroids here. Now we try to implement k-means. The main algorithm is here. We iterate for 20 times just to make sure we get the right centroids or k-means for the clusters. So take the data and centroids and find their distances into D, and use this distance to find their groups, and using these groups and update the centroids. So these 3 steps are gonna repeat. So if there is any case that the centroids became nans, which is not useful, in that case I'm making sure to reassign to a new set of random values. That helps to converge and get the right clusters and right means. And every time I'm plotting the updated centroids on the graph to see, and updating the C values with the centroids, and I'm running it for 10 times without stopping. Once it reaches 10, and I'm just checking whether my previous centroid is same as my current centroid. If that is the case, then we're gonna stop the algorithm, right? So this is entire algorithm. As you can see, we started somewhere here, 54 minus 96 and 2650. So 2650 is here, 5490 minus 96 is here, and in the next iteration we have seen 2549. That means this point is moved a bit, 25 and 49, and the other point is at 5496, so it stayed the same. And as you observe, in the next iteration it fixated to those points 5496 and 2549. They're gonna stay like that for 10 times of iterations because we have fixated that. And after once it reached 11th step and 12th step, and it kind of stops because the centroid values are the same as the previous one. So at 12th step the loop break and came out of the loop, and now we got the clusters separated and we got the new centroids. Let's make use of linear algebra to visualize these clusters. So now I'm using line equations and slope and perpendicular slope, all these concepts, and wrote very simple functions here. And making use of these functions, I'll try to draw the lines to cut the segments. So when you have given 2 points, you can find the slope by the formula y2 minus y1 by x2 minus x1, and perpendicular slope is for any given m is minus 1 by m. And to get c value from this equation, what you do is c is equals to 0.1 minus slope into 0.0. Line passing through point and slope is get from here. So these are the points and these are the grouping information just for visualization. It's pretty hard for us to understand this grouping, hence we kind of visualize this on a two-dimensional space. So for that, I started with a new fresh plot and plotted the base data first and then plotted the k-means with new centroids. That is base data without any clusters and the data with two means. And then I find line passing through the centroid 0 with slope m and line passing through centroid 1 with slope m, and I use line equation to plot those lines. Similarly, a perpendicular line come from minus 1 by m and I plot that line as well, and I took the mean of the two lines to plot the center line which is cutting the cluster. So I use this G to get categories and color map to color in R and G. So let's see how it look like. So this is line passing through the centroid, line passing through the centroids. The mean value is here in the red color, which is separating these two clusters, and the perpendicular slope is this, which is passing through these two centroids, and the clusters are clearly segmented into two, one in red color, one green color with this line. And we can also use Seaborn for this purpose. For that, we are using RGB palette with two colors, and we are getting unique color labels from G, and we are creating color mapping and using these information, like you can plot scatter plot from Seaborn with X and Y and U as G, and line plot just to draw this line. So 0 represent this data, 1 represent this data, and this line is cutting this curve. Okay, hope that helps you understand the concept of clustering using k-means, and hands-on helps you understand the mathematics behind it. In this series, I would like to take you further with some other types of algorithms in clustering and demonstrate practical applications using that in the future videos. Thank you for watching. Please do share with your friends. Don't forget to like, comment, and subscribe.